Now, second problem for pyramid. A pentagonal pyramid 35 mm base edge and 70 mm height is resting on HP with one of its triangular surface perpendicular to HP and parallel and nearer to the BP. Draw its projection. This question was asked in December 12 for 15 marks. So obviously since it is a pyramid, it is a three-stage problem. For first stage, since the base edge that pyramid is resting on the HP on one of its triangular surface perpendicular to HP. So first I'll assume the entire base lying in the HP, then I'll tilt that pyramid such that the triangular surface will become perpendicular to HP in second stage. Then we'll move to the third stage. So first I'll start with keeping the base entirely in the HP. So I'll get the true shape of the base, which is a pentagon below XY line. Again, while drawing the pentagonal base, we need to decide whether to keep a corner or edge on the right hand side. Since we want triangular face to be perpendicular in HP for second stage, so in that case we need to keep the one of the edge perpendicular to XY and on the right hand side. Then only we can tilt the that triangular surface containing that base edge, and we can draw it perpendicular to HP in second stage. So first I'll draw the pentagonal base with one of the base edge perpendicular to XY and on the right, keeping that base edge on the right hand side. As done in the previous first question for pyramid, we'll follow the same method. Here the base edge for pentagon is given as 35 mm. So we'll draw the pentagonal base of 35 mm. So first leave some space below XY because after marking the angle it should not cut the XY line. Then mark the angles 108 on both the sides. Be careful while measuring the angles. Measure them in a proper direction. Most of the students make mistake while drawing pentagon because they measure the angle wrong. So 108 for this side, and then again 108. Then we'll produce the two edges and we'll mark 35 mm on that. Now I will take this 35 mm in the compass and we can produce the remaining two edges using the same arcs and same length in the compass. So this is the usual method we already followed in prism and previous question of pyramid. So I'll make that base dark. Again, one more thing we need to remember about pyramid, that slant edges are also visible in the top view, but not as a true length but apparent view. So I need to, for marking the slant edges, I need to first locate the center, and for that the method is joining the midpoints of opposite sides with opposite corners. So for that I need to, the total edge is 35, so half of that will be 17.5. For one more side I need to mark midpoint of that. Then we'll locate the center of the base, the pentagon. So this will give me the apex. We'll first name the pentagon 2, 3, 4, 5. Here only one base is there, so like prism did not write ABCD also. So along with corners, base edges, I need to show the slant edges. So joining with the center of the base with each corner will give me the slant edges which are apparent in top view. Now we'll complete the front view. For that, axis height is given as 70 mm. So again, no need to project all the corners up to 70 mm above XY. You need to just project the axis up to 70 mm. And then remaining corners you need to just project up to XY, because in the top view, in the front view, we are going to get triangular shape and not rectangular since it is a pyramid. So first I'll mark the 70 mm length to mark the apex in the front view. So this point will give me the apex. This OO. So O dash, O dash. Now I'll project the remaining corners. 3, 4 already projected. Then from 2 and 5 I'll get the single projector. And then remaining is 0.1. Then I need to draw the slant edges. So boundary, they are lying with the slant edges which are lying on the boundary should be dark. Then base is entirely visible, so it should be made dark. Then slant edge from 2, observer is looking from this direction, will be visible, will coincide with slant edge from 5, so that should be dark. The first stage is same compared as that of first question, and again the axis long dash short dash. Okay. I will transfer the notations from top view to front view. 3 dash 4 dash, 2 dash 5 dash and 1 dash. Now in second stage, the condition is given the triangular surface perpendicular to HP. Now the triangular surface O34 from the top view, which is the apparent view, is nothing but a line 3 dash 4 dash O dash. This inclined line is nothing but a triangular surface in front view. Now I need to make this line perpendicular to HP. So this slant, that inclined line, I should make exactly perpendicular and redraw this front view as it is. So for that, I'll first mark this point 3 dash 4 dash, because while making the triangular surface perpendicular to HP, I should keep this base edge 3 dash 4 dash still in the HP. So I'll first start with 3 dash 4 dash. I'll draw the perpendicular at 3 dash 4 dash. And on that perpendicular, I'll mark the slant edge, because we need to, the slant edge is, this edge is nothing but a triangular surface, and we want to make that triangular surface perpendicular to HP. So that's why a vertical line. Now this front view we need to redraw. So with same point 3 dash 4 dash, I'll cut the arc for 1 dash. Then we have got this O dash, so I'll take distance from O dash to 1 dash, and I'll cut the previously marked arc for 1 dash. So this will give me this outer triangle. So this base is now losing the contact with HP, and only part of the base in contact will be this edge 3 4. That means 3 dash 4 dash. Again the boundary will be dark, so I'll redraw that front view after making the triangular surface perpendicular. to the HP. Now this end point is 1 dash, this is O dash. Now mark the remaining points on the base, which are O dash and then 2 dash and 5 dash. I'll redraw with the same visibility. So this point is O dash, then 2 dash, comma 5 dash. So O dash to A dash, long dash, short dash, light line. And then 2 dash, 5 dash, O dash is a dark line. Now corresponding to this front view, we'll complete the top view in second stage. By dropping the projectors. Now we can do it fast because we have already solved some problems like this. We will not miss the time in dropping the projectors. Now dropping the projectors from top view in the first stage. Now marking the corresponding points 1 dash 1 and 1, 2 and 5, so 5 will be here, 2 will be here, then O dash, so O will be here, 3 and 4, so 4 is here and 3 is here. Again the apex will be here. Now for visibility, marking the visibility, I need to first show the direction of observer. Now for the observer, portion above this line will be visible. So the entire base, which is 1, 2, 3, 4, 5 is not visible to the observer, but if any edges are lying on the boundary, then they should be dark. So I'll see out of the 5 edges of the base which are lying on the boundary. So 1, 2 is obviously lying on the boundary, so I'll make it dark. Then 2, 3 is also dark. And 3, 4 is also lying on the boundary. Then 4 to 5 is also lying on the boundary. And the remaining edge 1, 5 is also lying on the boundary. Means though the entire base is not visible to the observer from looking at the direction of observer, but since all the edges are lying on the boundary, as per the rule of visibility, they should be made dark. Now we'll move to the remaining edges. So after base, we will see the slant edges. So out of the slant edges, 1 dash O dash and 2 dash 5 dash O dash are nearer to the observer. They should be visible. But since 3 dash 4 dash is the farthest point for the observer, so edges starting from 3 and 4 should be light. So first I'll join the visible edges, that is 1 dash to O dash. Now see here, this O is the center of the base and this O is the apex. So I need to join for slant edges with this O and not with this O. So this is the apex, so I'll join each corner with this O only. So as we have discussed, O1, O2 and O5 will be dark. The remaining two corners are 3 and 4. So O3 and O4 are already coinciding with the base edge 3, 4, which is dark. So no need to draw it again. So this completes the second stage for the problem. Now in the third stage, we need to consider the condition given for VP. Now the problem says the triangular surface perpendicular to HP and parallel and nearer to VP. That means the condition with the VP is given for the same triangular surface. Means the triangular surface 3 dash 4 dash O dash, now which is a straight line 3, O, 4 in top view, this straight line now again I have to make parallel and nearer to VP. Nearer to VP means nearer to XY. If the condition given is nearer to observer, then this parallel line should be drawn nearer to observer. That means away from XY. But here it is asked nearer to VP. So I'll draw this line 3, 4 parallel and nearer, means I need to make this line parallel to XY and nearer to XY. So I'll redraw this entire top view in second stage with the base edge 3, 4 parallel. So for that again I'll follow the method of rectangle. I'll first include the entire top view in a rectangle. Then I'll redraw this rectangle first. Then we'll mark the points accordingly. So first I'll draw a line parallel to XY. Okay. And on that line I'll mark this much base edge 3 to 4. Okay. No, initially we will take entire rectangle, then we'll mark 3 and 4. But if I'm making this edge of the rectangle parallel, then obviously 3 and will also become parallel. So first I'll make the rectangle okay. Now to mark these two sides, I'll draw vertical lines which will be obviously perpendicular to the horizontal line. So I'll just use the roller scale without using the protractor. Now I'll mark this length. So I have to simply just rotate this entire top view by 90 degrees. So after marking this 2 halves, I'll complete the rectangle. Now the entire top view will lie within this rectangle. Many of the students reach up to the second stage, but they get confused while drawing the third stage. So follow the method of rectangle to avoid the confusion. Now obviously this corner is nothing but this corner, and this has gone to this place. So now with respect to that, I'll mark all the points. So first I'll mark O, which is the center of this. It will give me this. Then from this corner I'll mark 4. And obviously whatever is the distance for 4 from this corner, I'll get the same distance for 3 from the opposite corner. So from both the opposite corners, I'll mark 4 and 3. Okay. So this point is 4, this point is O, and this point is 3. Now on this edge, means this vertical edge, on the side of 4, I can take this distance to mark 5. So this point will give me, this arc will give me 5. Again, by the same distance, I can mark 2 from opposite corner. So I'll get 5 and 2. Now obviously one will lie on the same that line, dividing line from O. So we already marked O, so I'll just reduce that to get 1, where it intersects the other boundary of rectangle. So here I am going to get point 1. So I'll just join all those points to redraw this top view again. So 4 to 5, 5 to 1, 1 to 2, then 2 to 3, then 3 to 4, and along with the base edges I need to also show the slant edges 4 to 1, 4 to 5 with the same visibility, then 4 to 2, and obviously O23 and O24 already drawn. Okay. Now here we got the all points by just marking the arcs, so no need to draw these lines in the rectangle. So I'll just use this to get the final view. So I'll drop the projectors from each corner. Three, and then last is 2. I'll drop the projectors from front view also. 4 dash, 2 dash, 5 dash, 1 dash, and again the apex 4 dash. Okay. Now I'll first name the points. I think we have forgot to mark this O, which is the center of the base. So I'll just mark that point also. Now we'll locate each point in front view, final front view. So 5 and 5 dash will give me 5 dash here, then 2 again on the same line, so 2 dash, then 1 here, 1 dash, then 4 dash will be on the base, that is will be on the xy line, so 4 dash, and again 3 will be on the xy line. So I'll get the base here, then apex is at the top on the same center line, so I'll get O dash here. Then for center of the base, from this O dash, I'll get O again on the same line, so O dash. Okay. Now to mark the visibility in final view, I need to first see the direction of observer. Now, first rule is boundary should be dark. So whatever is the line on the boundary, I'll make it dark. So on the boundary, I can see the slant edge O dash 5 dash, the slant edge O dash 2 dash, then base edge 5 dash 4 dash, base edge 3 dash 4 dash, base edge 2 dash 3 dash. So whatever is the line on the boundary, I've made that first dark. Now we will see the edge is nearer to the observer. Okay. So 1 2 and 1 5 are nearer to observer, so those should be marked dark. So remaining base edges 1 dash 5 dash and 1 dash 2 dash should be dark because they are nearer to the observer. Now we have completed all 5 base edges and 2 slant edges. So now we'll see how to mark the remaining slant edges. Now we can see the points 4 and 3 are farthest from the observer. So we'll draw all the lines passing through 4 dotted. But already 2 lines from 3 and 4 are drawn dark because they are lying on the boundary. So remaining line, which are the slant edges O dash 4 dash and O dash 3 dash, should be made dotted because they are the farthest points from the observer. So lines from the farthest corner should be dotted if they are not lying on the boundary. So this line should be dotted, and again 3 dash O dash should be dotted. And remaining slant edges O dash 1 dash, since 1 dash is nearer to the observer, so slant edge from that point should be dark. Now marking the axis, the last part, O dash to O dash, but out of that O dash to 1 dash is already made dark, so only this part is the axis, which can be shown as long dash short dash. Now this completes the solution, and the last part remaining is showing the dimensions. So I'll show the dimensions here. The base edge is 35 mm. Then the axis height is 70 mm. Angles are not given, that means one is perpendicular and one is parallel, so no need to show that. So this completes the solution for this particular problem.